All right, we've been talking about the three forms of a quadratic and writing the equations in those three forms. So we're going to continue with that today. Here we're given a vertex and a point. Now when we have the vertex, we also have the axis symmetry. So remember that cuts it right in the middle there through our vertex. And whatever happens to the left must also happen to the right. So we are actually being given a third point right there in order to have our quadratic. Now, anytime that we have the vertex, the easiest way to write the equation is in the vertex form, a times x minus h squared plus k. H and k are the x and y value of the vertex. So my x value is the h, my y value is the k. So I would plug in the -3 for my h. When I do that, minus a negative turns that into a plus. And then I would plug in the 4 for my k. So I've got this part so far. Now to make it this exact quadratic, I need to figure out what the a value is. In order to do that, every single point on this quadratic comes from this equation. So I have a bunch of x and y values that I can plug in to get that a value. So I'm going to go ahead and take this point of -4, 1 and plug it in. I plug in 1 for the y value and -4 for the x. Now we are ready to solve for this a value because we have a one variable equation. -4 plus 3 is -1, squared is 1, so we get a plus 4. I subtract my 4, and a is equal to -3. Once we have that a value, then we can go ahead and plug that in for the a, and then I have that x plus 3 squared plus 4. And there is the equation for our graph here. On the second example, we're given a vertex at 3, -2, and then we're given a point at 4, 0. Again, the axis of symmetry cuts right through the middle of this parabola. And so whatever happens to the right also happens to the left, so we also have a point at 2, 0. There's our quadratic. This one I'm going to do in the factored form so I could review that part. Anytime that we have the two roots, you can write the equation in the factored form, and that's a times x minus r1, x minus r2. R1 and R2 are our roots, so 2 and 4 are going to be our R1 and R2. So I'm going to plug that in, and I get x minus 2, x minus 4. Notice that minus is part of the formula. It is always x minus the root. Now again, we have to figure out what the a value is to get this exact parabola right here. And so we've used these 2 points right here, so I'm going to use the vertex to plug that in to figure out what a is. So I plug in -2 for the y and 3 for my x. Now it's time to simplify so that we can solve for that a. 3 minus 2 is 1, and 3 minus 4 is -1. And so we get -2 is equal to -a, so a is equal to 2. Once we have that a value, we can plug that in, and we get 2 times x minus 2, which is my first root, times x minus 4, which is my second root. So that's with our roots, and then we had our vertex. Now let's talk about 3 random points. So 3 random points on this quadratic, you cannot do it in factored form or vertex form. If you think about your standard form, y equals ax squared plus bx plus c, this right here is my y-intercept, so I could plug in 8 for c, but that would still leave too many variables here in order to solve this. So we're going to talk about that in a little bit, but first let's do it with a calculator, which is what the best way to write the standard form is going to be in. So here are our notes on how to do that. When we are writing it in the standard form, we are going to go to Stat Edit. So here is my calculator. Stat Edit. In L1, I'm going to put the x values, and in L2, I'm going to put the y values. So if I'm given 3 points like this, I can go ahead and plug in -4, 0, and 7 for my x's, -8, 8, and -2.5 for my y's. We then hit stat again, and we want to go to calculate, and this time we want to do quadratic regression. You have done linear regression before. We're going to the quadratic regression this time because we want a quadratic equation. Here it's telling us the x is going in L1, the y is going in L2, which is what we did. The next part is this store regression equation. If you're going to use this equation after writing it, you're going to want to store it in the y equals so that you can look at the graph, so you can use the table, and so on. So we hit alpha trace right there, and that y1, or any of the y's, really, you can put it in. I'm going to go ahead and put it in y1. What that does is it calculates my equation and gives it to me right here on this front page, but it also goes ahead and puts it into the y equals. And it does not round, so using that equation is fantastic by storing it there so that you're not rounding too early. So right here, we would go to our a value and put in the negative 0.5. I'll just put it right here. Negative 0.5 x squared plus 2x plus 8. Because our a value goes right there, our b goes in front of the x, and our c is our constant that goes at the end. So we have written it in standard form. I'll show you what I mean by using the equation afterwards. So you're going to have some word problems that you're going to want to use. And the theory is just the same. You're going to want to come up with the 3 points so that you can put them into stat edit. So it says Van McSlugger needs one more home run to advance to the next round of the home run derby. On the last pitch, he takes a swing and makes contact. Initially, he hits the ball at 5 feet above the ground. At 32 feet from home plate, his ball was 23.7 feet in the air, and at 220 feet from home plate, his ball was 70 feet in the air. So the first thing I'm going to do is draw a picture. Not a very good one, but a picture. And there is my baseball that he has hit. It gives us certain information you're going to want to think about. So this first one here, it says it was hit at 5 feet above the ground. So when it is 0 feet from home plate, it is 5 feet in the air. So we've got that 0.05, our y-intercept. It then tells us that when we are 32 feet from home plate, it is 23.7 feet in the air. So we've got a second point at 32, 23.7. And then when it's 220 feet from home plate, it is 70 feet in the air. So those are the 3 points given. And so we want to use our calculator to try and write those. So we would get 0, 32, and 220 as the x values. And then for our y values that correspond, we have 5, 23.7, and 70. We have put the 3 points into our calculator here. Now we hit stat, calc, and we go to our quadratic regression. I have some more questions on this problem, so I definitely would want to store this. So again, I hit alpha trace y1, and we calculate. So it has given me this equation. When I write this on a piece of paper, I would want to go ahead and round because I don't want to put every single one of those decimals. But if I was using this equation, I would not want to round like this because it could mess up my final answers. Since I've stored it though, it goes ahead and copies and pastes it with the entire number, not rounding it for me. So now when I'm answering questions like, if Van's baseball needs to travel a distance of 399 feet in order to get to the home run, did he succeed? Explain why or why not. Well, since I've already put it in y1, I can go ahead and go to the table at 399 to see if that ball is still up in the air. So that's one option. I can find the root to see when the ball does land on the ground. There's another option. Since it's in y1, I've got those options. So I'm going to go ahead and go to 399 on the table of values. And at 399, it is still 13 feet up in the air, so it has not landed, and he did make it. $399, it is still at 13.26. So still in the air. I can go ahead and find the root, so I'll remind you of how to do that. I do it with putting in 0 and y2. That's when it would hit the ground, so there would be no vertical distance. And then I'm going to have to open up my window since we've already seen that at 399 it was still up in the air. So I'm going to go up to like 500. I'm going to make sure we keep this big enough to see the graph. And so here is the path of the ball. And then there's the ground. So if I hit second, trace, intersect, I move over to the side, enter, enter, enter. There it is at 419.99. So he went beyond that home run area. It did go far enough for him to get it. All right, there's also another question here. What was the maximum height of Van's baseball? Well, since it's in my calculator here, I can use that to find that vertex right there. I hit second trace, maximum, and I'm going to go somewhere on the left, and then again somewhere on the right, since it says left bound, and it's going to say right bound in a second. So I use my cursor to go to the left. I hit enter. Now it says right bound, so I'm going to go anywhere on the right. You want to make sure you go all the way around the curve, and then just anywhere on the right. Enter, and then enter for that guess, and there it is at 206.13 and 70.29. So our vertex point is 206.13, 70.3. And so the height was the y value, so there is our max height. All right, so using the calculator is really useful. It allows you to do it easily since the calculator is doing most of the work. Now we're going to talk about getting that standard form, though, without using the calculator. So we've attached some notes there for you guys to see. Let me focus that a little bit. You can't see them on the screen here, but they are attached to your Canvas, so you can see them a little bit better. But basically what this is telling you is that anytime that you have 3 points, you can create a 3-variable system, because in the standard form, you've got A, B, and C. So by plugging in these X and Y values, we will end up with a 3-variable system. All right, so here are 3 points. If you were going to do this without the calculator, we go back and we think about our standard form, ax squared plus bx plus c. Since I have x and y values here, I can make a 3-variable system with this with the a, b, and c. So for each one of these points, I will make a equation. I plug in the -2 for the y and the -2 for the x. And so I've plugged in this x value right there for the x's, and I've plugged in this -2 for the y. Then I can simplify, and there is my first 3-variable equation. I do the same thing now for my next one, -1, -5. I plug in the -5 for the y and the -1 for the x. I simplify, and there is my second equation. Now I've got one more to do, so I plug in the 1 for the y and the 1 for the x, and that gives us a plus b plus c. We now have 3 equations with the same 3 variables, a, b, and c. So I'm going to go ahead and write them here so that you can see it exactly the way you did when we did 3-variable systems. All we have to do now is solve with substitution or elimination or whatever method you prefer to do on a 3-variable system. So I think this one's going to be easy to eliminate our c values. So we'll go ahead and eliminate the c values. So I'll use these top 2 first. And I'm going to go ahead and multiply a negative times the second one. The first one I could leave alone. When we add these together, the c's are going to cancel out. And so we get 3 is equal to 3a minus b. I want to do the same thing now using the last equation, and so I pick either one of the equations. I'll just go ahead and pick that same one, that middle one, and multiply it times a 1 again. So we've got 5 is equal to negative a plus b minus c, and then my last one is 1 equals a plus b plus c. When I add these two together, the a's cancel out and the c's canceled out in this case, so we get 2b is equal to 6. I divide by 2, and 3 is equal to b. So we kind of got lucky on this one because it made it a little bit easier now that both the a and the c canceled out there and we have the b. So all I have to do is come back and substitute it here. So we get 3 is equal to 3a minus 3. I add the 3, and we get 6 is equal to 3a, divide by 3, a is equal to 2. And once we have 2 of them, we can always go back and get the third one, adding it in, substituting it into the one of the 3 equations. So I'll go ahead and substitute into that last one, and I get 1 is equal to 2 plus 3 plus c. So I've taken the 3 and plugged it in for the b. I've taken the 2 and plugged it in for the a, and all I need to do is solve for that c. Once you have that a, b, and c, then you can go ahead and write the equation. So I'm going to go ahead and write that. I get y is equal to 2 is my a value, x squared, my b is 3, so plus 3x, and my c is negative 4. That is what the calculator has done for you when you do the stat edit. It has written that equation for you by doing that quadratic regression. If you had to do it without a calculator, though, this is the way you would do it, by creating that 3-variable system and then solving. All right, we've got one more thing we're going to do today. We're going to go ahead and summarize that by writing our 3 forms of the quadratic here. You will definitely have to be able to write all 3 forms, so it's important that you can do that. It says, Tommy shot a bottle rocket off the top of his garage, which is 26 feet from the ground. The bottle rocket reaches a maximum height of 98 feet after 6 seconds and hits the ground after 13 seconds. Sketch a graph of the height as a function of time. So I'm going to go by 2's down here. And then I'm going to go by 20's on the y. That should give me a big enough picture to see what's going on. It tells us that he shot it from 26 feet up in the air. So that would be the 0.26 that they gave us, our y-intercept. It says it landed on the ground at 13 seconds, so that has to be our root there at 13.0. And it says he reached a maximum height of 98 after 6 seconds. So at 6, he is at 98, and here is our quadratic. One of the other things that it gives us indirectly without saying it exactly in there is the other root. Because you were given the vertex, you know that whatever happens to the right must also happen to the left. And so if this went 7 units to the right, it has to go 7 units to the left, giving me the point -1, 0. So we've got the vertex, we've got one root and another root. Plus we have the y-intercept here. Lots of good points there. The first thing I would want to do is pick which function I'm going to write first so that I can find the a value. Once you find the a value with one of them, you've got the a value for all of them. So I'm going to start with my vertex form. And I get x minus 6, which is my x value of the vertex, squared plus 98, which is the y value of the vertex. To find that a value, I use any one of the other points. So I'm going to go ahead and use this one right here. I plug in 0 for my y and -1 for my x. Now we need to simplify. So -1 minus 6 is -7, squared is 49. we subtract the 98, and then we divide by 49. We get our a value is -2. Again, once you have the a value for one of them, you have the a value for all of them. So I get -2 on the factored form, x minus my first root, which is -1, so that turns it into a +1, and then x minus my second root, which is 13. For my vertex form, I've got the -2, and then x minus 6 squared plus 98, which was my vertex. For the standard form, I either FOIL out this first one, the factored form, or I multiply all of this one out. Either one is going to work. So I'm going to go ahead and come over here so that I can show you how that works. So we've got our vertex form like this. And so we get y is equal to -2. I FOIL x minus 6 squared. Remember, that's x minus 6 times x minus 6. So we get x squared minus 12x plus 36. I now distribute that -2, and I get -2x squared plus 24x minus 72 plus 98. And then our final is to go ahead and combine those like terms. And there is our standard form. So we've got -2x squared plus 24x plus 26. We've written all three forms for that one equation.